Hello, everyone. I'm Aniket Daptari. I'm one of the product managers for CONTRAIL, the solution for cloud networking at Juniper Networks. And the topic I'm here to talk about is open source multi-tenancy in VMware clusters, and particularly I'll be talking about how OpenContrail helps you implement that open source solution for multi-tenancy in VMware clusters. Now, I'll keep the agenda real simple. I'll quickly introduce what OpenContrail is, and then I'll talk about the relevance of OpenContrail and secure multi-tenancy within the VMware ecosystem. And we'll quickly touch upon a customer use case who's using us in that context. And like what Alistair just told me, Q&A is going to be outside. So a quick product overview. We are all here at the OpenStack Summit. OpenStack is the orchestrator you see at the top. The top box is not just OpenStack, but other orchestrators like VMware's vCENTER and others like IBM Smart Cloud Orchestrator and so on. The role of the orchestrator, as we all know, is a framework to express app intent in a method or a manner that's agnostic to the way things are implemented. And the network portion of this abstract app intent is handed to the next box that you see, which is the CONTRAIL's controller. The controller plays the role of a network compiler here and translates this abstract description of the app intent, what the app expects from the underlying infrastructure, specifically on the aspect of networking. What does the app expect from the infrastructure? That gets handed in the abstract fashion to the controller. The controller plays the role of a network compiler, translates that into low-level constructs like routes, firewall filters, routing instances, or VRFs. Things that the developer either does not know or does not want to know or does not want to be concerned with. They don't want to know what underlying technology is going to be used to implement those things. What the app developer is concerned about is isolation. So if they are deploying multiple tiers, they want their tiers to be isolated from each other and so on. And they express those requirements using the orchestrator. The controller translates those into the low-level constructs and then programs these low-level constructs, the routes, firewall filters, routing instances, programs those into the distributed forwarding elements. So if we are here to talk about networking, most of us might be familiar with typical network equipment, which has a control plane implemented in a centralized routing engine or a supervisor kind of a device, and then they have distributed forwarding plane. So that exact same model exists here, where the control plane is implemented in a centralized fashion in the controller. It is logically centralized, but physically it may be distributed. And then the forwarding happens in a fully distributed fashion in the form of the vRouter software, which is implemented as a kernel module inside every x86 box within the data center. And then the vRouters also play the role of a fully distributed firewall, allowing policy to be implemented at the vRouter and therefore at the host itself. And the one other thing that this entire solution is based on is BGP control plane and IPVPNs in the data plane. And therefore, the role of the vRouters is to establish these IPVPNs, which essentially are the building blocks for implementing the isolation. So in the context of OpenStack, there are multiple hypervisors and different applications have different needs. And KVM is one of the most popular hypervisors. And a lot of the open ecosystem is centered around KVM. But we have to give credit to VMware that they were the pioneers in bringing compute virtualization and bringing server virtualization and making it mainstream, making it available to all of us. And therefore, there's a significant install base of VMware, both on the side of the hypervisor, ESXi, as well as on the side of the orchestrator like VMware's vCENTER. But the problem with that is they try to have an answer to multi-tenancy in the VMware clusters in the form of NSX. But some of the problems with NSX, and this is what we are hearing from some of our customers, is that they lock you into the closed ecosystem. A lot of the customers who are here at OpenStack Summit want to embrace the open ecosystem and want to move towards the open ecosystem and embrace open source hypervisors like KVM, for example. And the open source multi-tenancy solution that I'm going to be talking about enables customers of ours to perform that migration and provides a solution that seamlessly straddles across both the open environments of open ecosystems of KVM and OpenStack, but also straddles across to ESXi as the hypervisor and vCENTER as the orchestrator. So this is what things look like. Now, as I talked in the product architecture slide, the vRouter is the venue for implementing distributed forwarding and implementing distributed firewalls. As a result of that, the vRouter needs to be the default gateway on every host. All the tenant workloads, all the traffic needs to first be sent to the vRouter, and from then on, the vRouter inspects its VRFs and routing instances and makes forwarding decisions, and also implements the policy, and also puts on the encapsulation and sends it over the IPVPN overlay tunnels. So the vRouter needs to be the default gateway. Now, in the in the KVM side, in the Linux side, the vRouter is installed as a kernel module. But the VMware ecosystem being a closed one, nobody other than VMware can have something like a kernel module or the equivalent of a kernel module. Therefore, in our case, what we have to do is run the vRouter as a kernel module inside a virtual machine that runs on every ESXi host. So that's what you see here on the left, top left, as that's running as a CONTRAIL VM, and then you have a user space agent that communicates upwards, northbound to the controller and southbound to the kernel module, and then you see the vRouter kernel module itself inside the kernel of that virtual machine. Now, because the vRouter has to be the default gateway, you have to do some plumbing. All the tenant workloads that you see on that ESXi host in the form of those virtual machines, VM, G2, and VM R2 and R3, belonging to different tenants or belonging to different networks, a green network and a red network, all that traffic needs to be plumbed to the vRouter, and the vRouter performs its lookups and looks up the routing instances and VRFs, and then maybe puts on an encap, and then sends the traffic down on the wire to the physical NIC. So in order to do this plumbing, to implement this plumbing, we have recourse of the constructs that VMware provides to us, which is the VMware's distributed switches, and then the construct of networks or virtual networks that are the fundamental building blocks of tenant isolation. Those translate in the VMware world into port groups, distributed port groups. So on this particular slide, we see a green port group and a red port group, and these are distributed port groups sitting on the distributed vSwitch. So wherever there are tenant workloads belonging to those networks, you would have corresponding port groups created on those ESXi hosts on the distributed vSwitch. The other thing about the solution is that these virtual networks can transcend across the VMware world, the VMware cluster, and extend into the KVM side. So you could have a cluster of machines that are implementing OpenStack and the KVM hypervisor sit alongside this cluster and have a single network segment. If we look at this slide, maybe the green virtual network extend into the KVM side, and you could have some KVM virtual machines hanging off of the same network. So that's really the benefit of the solution, that the same set of network primitives extend across different environments. Let's look at some of the options we have for integration. And now, integration with VMware would happen on two fronts. It would be on the front of the ESXi hypervisor, so supporting ESXi workloads, supporting ESXi virtual machines, and supporting VMware's vCENTER as the orchestrator. So these are the four options that you see on this slide that we have in terms of integration with VMware. So the option one that you see on the top left, that was In the older OpenStack releases, we had the Nova ESXi drivers that allowed us to spawn ESXi virtual machines using OpenStack. And as you can see, there is a OpenContrail controller sitting underneath OpenStack that straddles across both KVM and ESXi environments. VMware went on to subsequently deprecate those drivers, so we had to move on to the other alternatives we have. The option 2 we see has no OpenStack in the picture. For various reasons, our customers may choose to use OpenContrail or alternatives to NSX, and option 2 is that alternative where we integrate with vCenter as a hypervisor and supporting ESXi, vCenter as the orchestrator, ESXi as a hypervisor. And if you launch another cluster with KVM and OpenContrail, those controllers in the two separate clusters can federate with each other and allow the networks to seamlessly straddle. Option 3 is the new set of OpenStack drivers, the vCenter driver for Nova. So when you use OpenStack to launch any ESXi virtual machines, they are handed to VMware vCenter. vCenter uses its own scheduling algorithms to schedule the ESXi workload, allows both KVM and ESXi to coexist with just one installation of the controller, instantiation of the controller. Option 4 does not need the vRouter to be present inside a virtual machine on the host, and we use the top-of-rack switches to do the translation between the IPVPN VXLAN tunnels and on the other side into corresponding VLANs that map into the ESXi virtual machines. This is what the option 4 could look like, but since I've covered, I'll just... a quick customer use case. We have a customer who's deploying an industrial internet. They have large industrial customers who use medical devices and other industrial equipment. They are building an analytics cloud for their customers, and they are using OpenContrail as the secure multi-tenancy solution in that VMware environment. Feel free to follow me on Twitter and write to us at contrail-plm@juniper.net, and we can talk about some of the customer details of the customer use cases and so on. Thank you.